Hello, everyone. Yes, I'm going to do Newton's second law, and then we're going to look at a question paper here. And then, yeah, basically, we're going to use this question paper to see how we can make Newton's second law easy, Yeah. So we have a question here. It's question 3 from the one of the previous question papers. So it says that a box with a mass of 45 kg is pulled with a force of 90 newtons at an angle of 50 degrees to the horizontal. The box moves at a constant velocity. And then we're also given a diagram here. So what we're going to do is that we're going to highlight the information that is given to us. Okay, so we're going to highlight the important information that is given to us. Well, it says that a box with a mass of 45 kg is pulled with a force of 90 newtons at an angle of 50 degrees to the horizontal. The box moves with a constant velocity. This part is very important. The constant velocity. You can see also that they also give that with a sort of like capital letters to indicate that that is an important information, right? Okay, so we can see from our diagram that we have the applied force, which is 90 newtons at an angle of 50 degrees to the horizontal. Okay, and then the first question here, it says that define the term kinetic frictional force. And then the second question, it says state Newton's first law of motion in words. But I'm not gonna focus on definitions because I think that is very simple. You just need to memorize them or maybe study them, yeah. But you don't need, I don't need to do definitions because that will just be a waste of time for now, yeah. Basically, I'm gonna go straight to the calculations, right? Okay, so now let's look at question 3.3. So if you look at question 3.3, they said calculate the magnitude of the horizontal component of the applied force. So this is the question that I'm looking at. So before we answer that question, I'm gonna write a free body diagram. Most of the time when you answer these questions, first of all, the important thing is to write the free body diagram of the diagram that you have, okay? So let's start first with the free body diagram. Okay, so the free body diagram here is a dot. The object is represented with a dot, right? So this is our object. And then we have the applied force. This is the applied force here. I'm going to represent it with FA. And then we also have the weight because we have the mass. So the weight is there. And then also we have because we have the surface, also the surface exerts a force which we call that normal force. I'm going to represent the normal force with N. And then we also have the friction because we know that the box moves with a constant velocity, meaning that there is a force that opposes the motion to make the F net to be 0. So in this case, we have the frictional force opposite to the applied force, okay? So this is the frictional force, kinetic frictional force, okay? So this is our free body diagram indicating all the forces that are acting upon an object, right? So now with this, we can see that the applied force acts at a certain angle from the what? From the horizontal. So we can see that from the horizontal, we have the angle there, which is what? 50 degrees. So with this angle, we're gonna be able to find the component of the applied force. We have the horizontal component, and then we also have the parallel component, and then we also have the vertical component, which is the perpendicular component. So 3.3, the question is to find the magnitude of the horizontal component, which we call that the F parallel. So that is 3.3. So now I'm going to write it here, 3.3. So if we are going to look at the horizontal component of the applied force, which is FA parallel, the parallel component of it. So, which is the horizontal component. Okay, so we know that the horizontal component or the parallel component of the applied force is going to be the applied force itself multiply with the cos, right? Cos of the angle that we have. Okay, so now the applied force is given as 90 degrees, 90 Newton. And then we have cos of the angle, which the angle that we have is 50 degrees, right? And then this will give us, when you use your calculator, that would be cos of 50 degrees. That will give you 57.85. So we have 57.85 newtons. Our F horizontal, or should I say the parallel component of applied force, right? And then 3.4, the question there is, the question says calculate the magnitude of the normal force. So if you look at the magnitude of the normal force, what we need here, I'm gonna break the applied force into two components from our free body diagram. So I'm gonna represent the components of the applied force into two components. So we have here, we have the parallel component or the horizontal component of the applied force, which is FA parallel. And then we have the perpendicular component or FA perpendicular, right? So these are the components of the applied force. So now we're gonna use that to find the magnitude of the normal force. So what we do here, our focus is to, should I say, make sure that we look at only the forces that are perpendicular to the surface, the forces that are perpendicular to the surface. So as you can look at our free body diagram, these are the forces that are perpendicular to the surface, that are perpendicular to the surface. So what we do with those forces, we're gonna add them and then say they equal to 0. What we mean by that is that, as we can see, that the object is not moving up or down, but rather is moving from left to right, right? Meaning that there is no movement on the vertical part of the diagram, meaning that the F net on the perpendicular side or perpendicular direction of the, should I say, the perpendicular direction of the surface is 0. So what we do here, we're gonna say, okay, if that is the case, we just write it down that F net perpendicular to the surface is equal to 0 because the object is not moving up or down. Therefore, if the object is not moving up or down, meaning that there is no acceleration, and then if there's no acceleration, meaning that there is no net force in that, or net force is 0, right? All the forces, when you add them together, they give you 0. So, but before I do that, let me just write this, because this equation is very important. I'll just write it so that at least we work with it, which is Newton's second law, where the information comes from. So we said F net is equals to MA. This is the Newton's second law. And then we write that because the acceleration on the vertical component. So what we are trying to say is that F net on the vertical component or the perpendicular component of the surface is 0 because the object is not moving up or down, meaning that there is no acceleration. And therefore, if there is no acceleration, meaning that there is no net force on the perpendicular direction of our object, right? So meaning that, what are the forces that are acting perpendicular to the surface? So these are the forces, like I have highlighted them in our free body diagram, the green part. So the forces that we have that are perpendicular that are perpendicular to the surface, we have the normal force. So I'm going to take upward as a positive in this case. So normal force is positive, and then also the applied force, but the perpendicular component of the applied force is also positive. And then we have weight, but weight here is negative. So I'm going to put plus minus weight, and then this is equals to 0, right? So these are the three forces that are acting perpendicular to the surface. So we know that the reason we do that is because we want the normal force. So normal force is the one that is acting perpendicular to the surface, and then also the other forces that are associated with the normal force. We have the applied force, that is the component perpendicular, and then the weight, right? So with this now, we don't know the normal force. We want to find the normal force. So with this, you will write that normal force. Therefore, when you take, because weight is negative, when you take it to the right-hand side of our equation, is going to be positive. And then F applied perpendicular will now be negative because it's positive. It will now, when you take it to the right-hand side, it's going to be negative, right? So that is the F applied perpendicular. And then when you write this down, it's now gonna be weight. We know that the formula for weight is what? Is mg, right? So if the formula for weight is mg, then we can write it down here. Okay, let me write it here. So weight, we know that weight is what? Is mg. So we just write it down in our equation here. Substitute for W, which is weight, we just write here mg. We write mg. Okay, so this is mg, and then minus the applied force, perpendicular component of the applied force will now be F applied force sine of theta. So when we substitute everything here, normal force is going to be the mass of the object, which is 45, multiplied by 9.8, because that is our gravitational acceleration, and then minus the applied force. The applied force is what? Is 90. So we substitute applied force, and then sine of the angle, which is 50 degrees, right? So therefore, the normal force, when you put 45 multiplied by 9.8, 45 multiplied by 9.8, that will give you 441. And then when you say 90 multiplied by sine of 50 degrees, that will give you 68.94. And then therefore, normal force will be 441 minus 68.94, which gives you 372.06 newtons. Okay, that is our normal force, right? So now that we have the normal force, I'm just going to write it here so that at least we erase the other part, right? So I'm just going to write it here that the normal force, our normal force here is what? The answer for 3.2, we got it as 372.06. And then also the magnitude of or should I say the magnitude of the horizontal component, I'm going to write the answer for 3.3 as well. We got it as the magnitude of the applied force parallel, we got it as 57.85. Okay, so that I can be able to create a space for myself. Okay, so with that now, I can now erase this part here so that I can have a space for 3.5. Okay. Okay, so yeah. Okay. Okay, so now let's look at 3.5. So 3.5, the question is calculate the coefficient of kinetic friction. And then we know that the coefficient of kinetic friction, the formula for friction or kinetic friction, okay, sorry. Okay, the formula for kinetic friction, we know that for 3.5, the kinetic friction is what? Fk, which is kinetic friction, is equals to coefficient of kinetic friction multiplied by the normal force, right? So, but that means that for us to be able to calculate coefficient of kinetic friction, we need kinetic friction, and then we also need the normal force, because if you now make coefficient of kinetic friction the subject to the formula, you're going to divide both sides by the normal force, and then therefore you will have coefficient of kinetic friction is equals to what? Is equals to Fk, which is the kinetic friction over the normal force. So we already have the normal force from this part, but now what we need is to calculate first the frictional force, right? If you look at from the diagram or the information that is given to us, you will see that one the part that I highlighted when we started is that constant velocity. They said that the box moves at a constant velocity. Meaning, what is the meaning of constant velocity? Even an object moves with a constant velocity. This is just a piece of information that we can also maybe highlight to indicate that is important. So what what is the implication of that is that constant constant velocity simply means that change in velocity, or there's no change in velocity, because if an object moves a constant velocity, meaning that there is no change of velocity. And then if there's no change of velocity, we know that acceleration is the rate of change of velocity. So if acceleration is the rate of change of velocity, if there is no change of velocity, meaning that the acceleration will also be equal to 0, right? And then if acceleration is equal to 0, according to Newton's second law, we know that Newton's second law is mass multiplied by acceleration, meaning that if there is no acceleration, because it will be mass multiplied by 0, therefore net force will be now also 0. So those are the important parts, that when the object moves with a constant velocity, means that acceleration is 0 and also net force is 0 in that horizontal direction, right? See, this is the important information. So just to highlight it, that the net force is 0. So if the net force is 0 in the horizontal direction as well, meaning that, let me just erase this part so that I can create space for myself. Okay. So if the net force on the horizontal direction is also 0, it means that we can be able to find the frictional force looking at this part. So if you look at this part here, the horizontal direction of our free body diagram, we only have two forces. We have the kinetic frictional force, and then we also have the parallel component of the applied force. So remember I said that the net force, that is where I'm going to start with. Net force is equals to MA, but we know that because the object moves with a constant velocity, therefore net force is equals to 0. And then what are the forces that are acting perpendicular or parallel to the surface? We have the Fk, and then we also have applied force. So I'm going to make applied force to be negative. That means that in this case, the left-hand side will be positive, and then the right-hand the right side of our diagram would be negative, right? So in this case, Fk is positive, and then F applied parallel component of it is negative. So meaning that Fk is equals to the F applied parallel or horizontal component. And then we already calculated the horizontal component of F applied from question 3.3. So we can say that if Fk is equals to horizontal component of the applied force, meaning that what we can write here, we can say that therefore Fk is also equals to 57.85 because we got horizontal component of applied force to be 57.85. So in this case, we now have our Fk, which we said that we're gonna use it equation. We're gonna use it in this equation here because we already have the normal force in order for us to calculate the coefficient of kinetic. For the coefficient of kinetic friction, the coefficient of kinetic friction here is the Fk, which is the kinetic frictional force over normal force. Fk, we got it as what? We got it as 57.85 over the normal force here. We got it from 3.4, and then I highlighted already, which is 372.06. So both are these forces. So Fk is measured in newtons, and then also normal force is a force which is measured in newtons, meaning that then the units is gonna will be cancelled out, and then therefore coefficient of kinetic friction is a unitless quantity, right? So that means that we have 57.85 divided by 57.85 divided by 372.06. That will give us 0. So we're gonna round it to decimal. So this will give us 0.16 if you round it off to 2 decimal place. That is the coefficient of kinetic friction. Okay, and now the last question, which is 3.6, is to calculate what? 3.6 is that will the coefficient of kinetic friction change if the angle of the applied force is decreased? Write only yes or no and give a reason for your answer. Okay, so with that, let me just remove this so that we can have a space. Okay, so that is 3.6. The question here is that will the coefficient of kinetic friction, which is calculated in 3.5, change if the angle of the applied force is decreased? Write only yes or no. So the answer for 3.6 will be no. Why no? The reason is that coefficient of kinetic friction, coefficient of kinetic friction or coefficient of friction is dependent on the type of material, of the surface and the object itself. Meaning that the coefficient of kinetic friction is independent of the angle, but is dependent on the type of material that the object and the surface is made up of, right? That is the reason why it will not change, because it's not dependent on the angle, but rather it's dependent on the type of material that the object is made up of, right? Okay. Yeah, that is Newton's second law. If you have any questions, you can type your question on the comment section.